With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Normally, solubility of a crystalline solid increases with temperature. Normally, solubility of crystalline solid increases with temperature. Does it increase uniformly in all cases? Name a substance whose solubility initially increases, then decreases with rise in temperature. Yes, normally the solubility of a crystalline solid increases with temperature, but it doesn't increase uniformly in all cases. And we have to tell a substance whose solubility increases initially, then decreases with rise in temperature. So here the substance is calcium sulfate. Calcium sulfate with the formula CaSO4. CaSO4, and it doesn't react with water, but it results in an hydrated salt. The maximum solubility it attains between 30 degree to 40 degrees Celsius. It is attained at the maximum solubility of calcium sulfate is attained at 30 to 40 degrees Celsius. Maximum solubility is attained at 30 to 40 degrees Celsius. So what happens here? This involves an exothermic reaction. This involves an exothermic reaction. So let us write the reaction. What happens? Ca, that is calcium sulfate, solid, forming calcium ion, that is aqueous, plus sulfate SO4, 2 minus ion, aqueous. So what happens in this? In this involves an exothermic reaction. It's an exothermic reaction. What do you mean by exothermic? That means in this system, heat is being evolved. Heat is being evolved on the product side. So here, heat is there on the product side. So what happens when we increase the temperature? As per the question, when we increase the temperature, what happens? When temperature increases, what happens? When temperature is increased, so when temperature is increased, there is a result of stress on the product side, because it is an exothermic reaction, and on the product side there is a stress. It results on a stress on the product side. So according to Le-Chatelier's principle, the system shifts towards the reactant side. The system shifts towards the reactant side. Here it shifts because there is a stress on the product side. So if we apply the Le-Chatelier's principle, it shifts towards the reactant side. Why it shifts towards the reactant side? To alleviate this stress. To alleviate this stress, it shifts towards the opposite side. When it shifts towards the reactant side, what happens? Less of solid is dissociated. Less of solid dissolves. That means there is a decreased solubility with rise in temperature. So let me re-explain this. When the temperature is increased, what happens? There is a stress on the product side. Stress on product side of the reaction increases. Stress on product side. Then what happens when there is a stress on the product side? What happens when there is a stress on the product side? If we apply the Le-Chatelier's principle, the system shifts towards the reactant side. System shifts towards reactant side. So why does it happen? To alleviate the stress, to compensate, alleviate the stress, to alleviate. This is according to the Le-Chatelier's principle. So when it shifts, what happens? The dissolving of the solid, that is the dissociation of the solid, becomes less. So this leads to decreased solubility. Leads to decreased solubility. So this decreased solubility is due to what? Increase in temperature. This is due to increase in temperature. So finally saying, what is happening here? It is an exothermic reaction. Hence, if it is exothermic reaction, heat is essentially present on the product side. And when you increase the temperature, this results on a stress on the product side. To compensate this, to alleviate this stress, the system shifts towards the reactant side. By shifting towards the reactant side, less solid is dissolved or dissociated, and this leads to less or the decreased solubility with increase in temperature. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.